Good afternoon, everyone. Oh, just Tabiso. Can you hear me there, Tabiso?
Yes, sir, I can hear you.
Okay, thanks, man. It's not going to be long. It's probably going to be half an hour. We're just going to do a few problems, small ones. Let's it's 5 already. So let me just check something here. If it's streaming nicely. Yes, it's streaming nicely. So we can start. Vusadi, hi there. Like I just told Tabiso, Tashinga. Like I just told them, it's gonna be a short session. So it's probably just half an hour, quick few problems, all based on, let me just share it now. Can you guys see what I'm sharing right now?
Yes.
Okay, thanks, Tashinga. Okay, so these problems are all based on wave motion. Okay, so they are like easy, very easy problems. Okay, the first one says find the period of a wave of 100-meter wavelength in deep water where. Now, that problem is actually a problem number 17 of, let me just go back, number 17. And it says find the period of a wave of 100-meter wavelength. So we have that this wave has a wavelength of 100 meters. And they say find its period in deep water where. Now this where is not in there, but actually it's supposed to be where v, the speed, is equal to the square root of g, the gravitational constant, times the wavelength over 2 pi. This is not written there. Okay, it says where and then where. This is what comes after. Okay, so they tell us or ask us to find a period of a wave of 100 meters wavelength. So this wave has a wavelength of 100 meters, and they want us to find the period. Now, we know that speed is equal to frequency times wavelength. And if you rewrite that, you will see that frequency is 1 over t. Well, frequency is 1 over t. So we can rewrite it as speed is equal to wavelength over time. Okay? Because frequency here is equal to 1 over t. Now continuing, if we make t the time the subject of the formula, we get that time is equal to wavelength over the speed. Okay? So wavelength over speed. Now we have wavelength and we have a formula for the speed. Thus, we can find the period, or as they call it here, the time. So if we rewrite it, that's wavelength over speed. The formula for speed that they gave us is g lambda, which is also wavelength, and 2 pi. That's the formula. They gave us that formula. So using this formula here, we can actually calculate the time it would take of a wave of 100 meters wavelength traveling at this speed here. Okay, how long it would take. Those of you who just came, welcome. I'm just going to erase that. Okay, so we had that velocity of, sorry, we are working with time. The time or period is equal to wavelength over g, which is gravitational constant, times lambda times 2 pi. They gave us this, that this is velocity. They gave this. Now if we substitute everything we know, okay, we have that the wavelength is 100. I'm not going to put in units. G is 9,81. Lambda is 100. And then 2 pi. If you were to calculate this on your calculator, I'm not going to do the whole calculation. But if you were to calculate it, you could punch it in on your calculator. You'll find that the answer is 8 seconds. It takes 8 seconds. Okay, 8 seconds. These are all trivial questions. Well, not trivial, they are easy. We can check. Let's check 8. There it is, correct. It's 8. Now let's move to question number 18. This is a fun part. 18. They ask us if y, this is a formula describing the wave, if y is equal to 0.02 sine of 30x minus 400t, all in SI units, of course. So there we have a formula for the wave. Okay, or those of you who did, if some of you are doing FEV, you would have done it with me in oscillations. Okay, now if the mass density of the string on which the wave propagates is 0.05 kilogram per meter, then the transmitted power is, now I will be doing, those FEV students of mine, I will be doing it next week, but I'm going to upload this video so long. Okay, you can follow along, but this will become relevant to you only next week when we actually do wave power propagation. Okay, now, but it's not difficult to follow along. We are given, or we should know, or you will learn that power is just a half times the mass density times the angular frequency squared times amplitude squared times its velocity. Okay, now everything else we need is already in that formula. Everything we need to calculate the power has been given to us in this formula. Okay, we know that this is the amplitude, so we already have the amplitude. So the amplitude is equal to 0.02 meters. Everything is in SI units, of course. The angular frequency, okay, the angular frequency has also been given to us. It is 400. This here, WT, it is 400. It's the angular frequency. It is 400 rads per second. The mu here has been given to us as the mass density of the string. It is 0.005 kilogram per meter. That's the mass density of the string. The wave number k is equal to 30. That's been given. And then of course, from that wave number, we can work out that the wavelength is 2 pi over k. So 2 pi divided by 30 is just 15. 2 pi over 30 is 2 pi over 30. So it's pi over 15. Pi over 15 is the wavelength, or approximately 0.21 meters. That's the wavelength. So we'll just be using this formula. So we have this, we have this, we have this, we have the mass density, we have the angular frequency, we have the amplitude, we just need the speed. And we just calculated the wavelength. And what else do we need for the speed of a wave? Okay. For the speed of a wave, we need the wavelength and frequency. So let's calculate the frequency. Then luckily there is a formula that relates frequency and angular frequency. Angular frequency divided by pi is equal to frequency, linear frequency. So that is 400 radians divided by 2 pi gives me 200 over pi, or just 63.66 hertz. That .66 hertz. That's the frequency. So we have the wavelength, we've worked it out. It's pi 0.21 meters. So speed is lambda times frequency, which is lambda we worked out was 0.21 meters. The frequency is 63 hertz, 63.66 hertz or per second. And that gives us a speed of 13.37 meters per second. So we have everything now. We literally have everything in this formula. This is the formula that we're using. It says power is equal to a half times the mass density times angular frequency squared times amplitude squared times the speed. And we have everything. We just calculated it, most of it. Well, most of it was given. The mass density is there, given to us as 0.005. Then the angular frequency is 400 rads. Don't worry if some of the things are a bit hazy to you. Those of you that do physics with me will find out soon enough what everything here means. Then you will have the luxury of enjoying these videos. Okay, so and the speed that we just worked out is 13.37. And if you multiply that all together, you get an answer of 2,1392 watts of power. Okay, or if you, that's approximately 2,13. And let's check the close. Yeah, they have a 2,13 there. There we have it, 2,13 as the answer. Let's check number 19. Those of you who just started with oscillatory motion with me, you'll find when you're watching this at a later date that you now understand everything in this section. Okay, 19. The same little problem, frequency. I think they put this problem out of order, okay? Because they first ask you the most difficult thing and then everything else is easy. Frequency is equal to angular frequency over 2 pi. Now the angular frequency is 400 and divided by 2 pi is 200 over pi. So that's 200 divided by 3. That's 63.3 63,6, sorry. 63,66. And we just calculated this. We just did. That's 19. I know I'm not going as slow, but this is basically you just need to plug stuff in. 20, for instance. Same thing. They want to calculate the wavelength, but they had us calculate the wavelength back at the beginning. Wavelength is equal to 2 pi over the wave number k. 2 pi over the wave number in this case is 30. Okay? The wave number is 30. So it's pi over 15. Meters. Pi over 15 meters. Not interested in the algebraic. Frequency here we got 200 over pi. There we have it. And then the frequency we just calculated it to be pi over 15. We upload these videos ahead of time. Well, so that when you need them, they are already there. Question number 21. Ocean waves with a wavelength of 120 meters. So, immediately write down it has a wavelength of 120 meters. They are coming in at a rate of 8 per minute. So, 8 per minute. That is its frequency. 8 per minute. 8 per minute. Now, if you convert that to per second, you multiply by 1 minute is equal to 60 seconds. So basically you're dividing by 60. And that gives us 0.13 hertz. That's the frequency. 0.13 hertz. So we have wavelength and frequency. They want the speed. We know that speed is equal to frequency times lambda, the wavelength. So frequency is 0.13 hertz multiplied by the wavelength of 120 meters. If you work it out in your calculator, you should get an answer of approximately 16 meters per second. The correct answer is 15.6. 15.6 meters per second. And if you round it off, it is then approximately 16 meters per second. And if we check the answers here, 16 meters per second. These are all very simple enough problems. 22. They ask us the speed of a 10 kilohertz sound wave in seawater is approximately 1,500 meters per second. What is its wavelength? We know that speed is equal to frequency multiplied by wavelength. We want the wavelength. So it will be speed over frequency. We have that the speed is 1,500 meters per second. And its frequency is 10,000. So 10 times 10 to the 3 hertz. Hertz is just per second. Therefore, the answer would be in meters because these two will cancel out. So whatever answer you get will be in meters. And that's going to be 0.15 meters or 15 centimeters. Let's check. And there it is, 15 centimeters. Last question for today. To transmit 4 times as much energy per unit time along a string. This is a one I have a problem with. 23. they ask us to transfer 4 times as much per energy per unit time along a string. You can. Now, to transfer power, you use this formula. P is equal to a half mu alpha squared angular frequency squared times velocity. Now, to get this 4 times as much as it originally is, you can either double this, you can double the amplitude, because if you double the amplitude, let's see what happens if you double the amplitude. Let's say we calculate power and we double the amplitude. 2 times the amplitude, we double the amplitude. A half times the mass density times 2 times amplitude squared, W squared V. The answer is then 4 times amplitude squared V squared. Now we can actually take out the 4, so it is just a half mu naught A squared omega squared V. So we have effectively transmitted 4 times the amount of power by just doubling the amplitude. Same thing, the same concept. If you double the angular frequency, you will get 4 times the power. If you double both of them, you will get 8 times. Well, 4 times the power. 4 times the power if you double one and you double the other one, you'll get 16 times the power if you double both of them. So in order to transmit 4 times the power, you just need to either double the amplitude, or you must double the angular frequency here, or you must make this constant 4 times bigger, or the speed must be 4 times bigger. So you need to double the frequency. Yes, you can double the angular frequency, or you can double the amplitude. You can both. If you increase the tension by a factor of 16, that won't work. You need to increase the tension by a factor of 4. You need to do any of the above. Oh, you can only do A and B above. That is the correct answer. You can only do A and B. Either double the frequency or double the amplitude. Okay. Now, that, ladies and gentlemen, is all that we have. It is about some simple questions based on work that the FVV class will do, but PHYV, I think you've already done it, so you might understand it. It is simple enough questions, and if you have a question regarding that, you can actually ask me right now. But that is all for today. It's just like a quick 23 minutes, nothing much. If you have done oscillations with me, and I don't know where Dr. David is now with his class, you will be able to understand that. But I just did it now so that when the time comes for you to study or something, that you already have this video doing these problems. That's all the time we have for today. Enjoy the rest of your weekend.